All right, so 3.5 derivatives of trig functions So I'm going to show you the long way to find the derivative of sine, and ultimately you're going to get what the derivative of sine is, and at that point you just need to memorize what it is, not necessarily how to get there. So find the derivative of sine of x. So we're going to use the definition of the derivative. So dy dx is equal to the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. Now, what you may not remember is called the angle sum identity, and so that's what's going to allow us to split this, so the sine of x plus h. So I'm going to carry the limit as h approaches 0 all the way down. So it's going to be of sine of x cosine h plus cosine x sine h minus the sine of x all over h. And I don't have room to write it on that side, so this is the angle sum identity. So if I do some moving things around, I can technically put this piece over here and all of that, okay? So what I'm going to do is, because both of these pieces, so here and here, since they both have a sine of x in them, I'm going to pull a sine of x out. So limit as h approaches 0 of the sine of x times the cosine of h minus 1. And then all that plus the cosine of x plus the sine of h all over h. Now, my properties of limits and all that stuff says that I can break this up into pieces. So it's going to give me the limit as h approaches 0 of the sine of x times the limit as h approaches 0 of the cosine of h minus 1 over h plus the limit as h approaches 0 of cosine of x times the limit, this isn't going to fit, as h approaches 0 of the sine of h over h. That sort of fit. So since there's no h in sine of x, that's just going to stay sine of x. This one over here is going to give us 0 plus, there's no h in cosine of x, so cosine of x. And then with that, that's going to give us times 1. So then that stuff's going away, so this is just leaving us with cosine of x. So the derivative of sine of x is equal to cosine x, is what all of that goes to show you. Now, you could do this with every single trig derivative if you wanted to, but I don't think you want to, and I certainly don't think you want to do that every time. So all you need to remember is that the derivative of sine of x is cosine of x. And then we're going to have each trig derivative, you're going to know what it's equal to.
This is in total called the angle sum identity?
No, just this step.
Okay. Yeah.
The step that got us from here to here,
Okay.
technically speaking, it's
What is
that
that
part.
step again?
Do what?
We take the right side of the equation.
What happened here?
Yeah.
Or I guess, hold on. Technically, this is not the angle sum identity. Why did I just write this? Hello, please work. Okay. The angle sum identity is what gets us from here. This is where I was supposed to draw it to. I just gets us from here to here.
Oh, okay.
So this piece gives us this, basically. So then what I did is, because there was a sine of x in two of the pieces, I combined those essentially and pulled out a sine of x to try to simplify things down as much as possible. I'm not going to expect y'all to replicate this. Basically, this is, if you ever go take a math class and they tell you you have to prove it, this is why it works. This is why it is what it is. You could do all of them, but I don't advise it. It's not really fun. I think your book does one of them for you. I may have just done the one that they do for you. Yeah, I think I just did the one that they did for you. Oh well. But you can find all of them this way. It just takes a long time. And then like your like tangent function, if you forget what that derivative is, you can use the fact that you know the derivative of sine and the derivative of cosine and use a quotient rule to find that derivative. If you forget it. Sometimes I forget, so I do that. Or you can simply just memorize them. You will need to know all 6 of them before the test, so just be aware of that. So I'm going to write down all of your trig derivatives. All right, so d dx of sine of x is the one we just found. That one is the cosine of x. d dx of the cosine of x is minus the sine of x. At a minimum, as long as you know these two, you can get the other 4, because the other 4 are made up of sine and cosine. Okay, technically speaking, but instead of going through all the work, you're probably just going to want to memorize them. So d dx of tangent of x is equal to secant squared of x. Now I'm just going to make a note reminder here that this is sine over cosine. So if you wanted to go try to figure it out, you could take the quotient rule of sine of x over cosine of x, and you could see if you actually get this out if you wanted to prove it and see that it works or whatever, but I'm not going to make you do that. Well, I might make you do that at some point, but I don't think I do. I don't remember. d dx of cosecant of x is equal to minus cosecant of x times the cotangent of x. d dx of the secant of x is equal to the secant of x times the tangent of x. And d dx of the cotangent of x is equal to minus the cosecant squared of x. So probably what I'll do, because what's going to happen is I'm going to give you your quizzes back from 3.1 to 3.4. That's the only thing from before break that I haven't graded yet. So once I grade those, I'll give those back to you. And then after we're done with this section, there'll be a test on the whole chapter. And then I'll see where we're at there to figure out if we're going to start chapter 4 at all or not. This is the last section in chapter 3. So we'll see what happens. So basically, earliest for a test is Thursday probably, but most likely it'll be like Friday. So, anyways. But make sure you know these. Why is this doing this? I'm determined to get it to actually make a little cloud bubble. Okay, whatever. It's just going to be boxed. That's just what's going to happen. All right, so make sure you know those. Probably what will happen, I don't think I finished the statement a minute ago, on the test is that I'll have like one of the first questions or the questions right before you need to use the trig derivatives. I'll have a question where you have to write all of them. I'm not going to tell you if it's extra credit or if it's actually a question on the test. Could be either one. I mix it up usually. But what I'll let you do is write them all and then bring it up to me so I can check them, because what you'll end up having is like product rules that include these in them, or quotient rules that include these in them. So I don't want you to just like get them wrong because you had a negative sign wrong or something like that. So that way I can check them and then you have those to use. You just have to understand whatever the product rule or quotient rule is that's using them, basically. All right, so we don't really talk about this in physics per se, but in calculus it comes up. It's called jerk. It is the derivative of acceleration if a body's position at time t is s of t, then the body's jerk at time t is j of t equal to dA dt is equal to d3s over dt3. Okay, this just is saying, the second part here is saying, or third part I guess in this particular equation, is the third derivative of position with respect to time is what that 3 being there means, which is essentially taking the derivative of acceleration. Okay, because remember, derivative of position gives you velocity, derivative of velocity gives you acceleration, and now you'll have that derivative of acceleration gives you jerk. Okay. And what you may want to do when you're going through and doing like your homework problems, you may want to write these trig derivatives on like a separate piece of paper or a note card or something, just so that you have them handy until you're used to them. It just helps a little bit. All right, so we're going to do a few problems, and then I'm going to give you guys some to do, and then we'll do the second part of this section tomorrow, where it gets a little more crazy, like finding the tangent line to the curve that we're dealing with now with respect to trig functions, and stuff like that. So all right, so these first problems say to find dy dx, and then it's like, yeah, anyways, okay, there's a little bit more to the instructions, but that's the part we're doing. So number 2, y is equal to 2 sine of x minus the tangent of x. So y prime, okay, is, we're going to take the derivative of this, okay, with respect to x. With these ones, okay, obviously with your other ones, if I gave you something like x squared plus x minus 3, the derivative of that would be 2x plus 1, blah, blah, blah. Okay, we do stuff with the exponents and all of that. And the numbers in front get multiplied, all that stuff. With trig functions, the number that's with it just moves down with it. Okay? So the derivative of sine is cosine, so that's just going to be 2 cosine of x. And then the derivative of tangent, okay, I never do anything with the sign here in terms of copying it down until I see what it is up here, okay, because if it's a negative and a negative, I'm going to make it positive and, you know, blah, blah, blah. So the derivative of tangent is secant squared, so that's going to be minus secant squared of x, and then you're done. Okay, so these ones, in some aspects are easier, and some aspects are harder because they require memorization. Some people think they're harder, but in terms of remembering, like, to move exponents all around and stuff like that, it's not too bad. Let's see. Number 6. So y is equal to 3x plus x tangent of x. So what do you notice about this problem that's different than the first one? Huh?
It's good. No.
The 3x, okay, so that's not, obviously that's not going to be a trig derivative, but we're still taking the derivative, okay, because we're taking the derivative of y with respect to x. What do you notice about this part? What is this going to give us? That's x times tangent of x, so what rule am I going to have to use?
The product rule.
Okay, I'm going to have to use a product rule for this one. So y prime is equal to, what's the derivative of 3x? 3. Then plus, so the first, copy it down, times the derivative of the second. So the derivative of tangent of x is secant squared of x. Plus the derivative of the first, which is 1, okay, times the second, which is tangent of x. And so that's all you have to do for that one. Okay, if it was like x squared tangent of x, obviously for that second part it would have been 2x tangent of x had that happened, but that's all you have to do for this one since it was a little bit more simple. But, well, I'll do it when we get down to it in the problem. Alright, so number 10, y is equal to cosine of x over 1 plus sine of x. Alright, so what rule do I have here? Quotient rule. So it's going to be the derivative of the top times the bottom minus the top times the derivative of the bottom. So y prime is equal to derivative of the top. So the derivative of cosine of x is minus sine of x. times the bottom, so 1 plus sine of x, minus the top, cosine of x, times the derivative of the bottom. The 1's going to go away. The derivative of sine of x is cosine of x. And then over the bottom squared, so 1 plus sine of x squared. And make sure, especially, I mean, I've typically said this when we've done quotient rules in general, but very specifically when we're doing trig quotient rules, leave this on the bottom as a squared term, because a lot of times the book is really nice and allows it to cancel with something. If you get down to where that's not true, then obviously you can factor it out, but I'm okay, even in your final answer, if it doesn't cancel, leaving it like this. There's no need to really multiply them. And a lot of times, if I remember correctly, in the AP like book that I have, they do that as well. They actually just leave it. So, all right, so now I'm going to multiply this stuff through here on top. So this gives me negative sine of x minus sine squared of x minus cosine squared of x all over 1 plus sine of x squared. So now's where I'm going to remind you of the Pythagorean identities. It's been a while and you've probably forgotten them, but sine squared plus cosine squared, and I'm not putting the x's in just for space, is equal to 1. 1 plus cotangent squared of x is equal to cosecant squared of x. Or I guess I am writing x's now. And tangent squared of x plus 1 is equal to secant squared of x. Okay, so these identities will be helpful in canceling stuff out. Okay, so right here, okay, these both have a negative in them. So I can take that negative out, okay, which would give me, just for this top part here, that would give me negative times the sine squared of x plus the cosine squared of x. It almost fits there. So then I can use my identity and replace sine squared of x plus cosine squared of x with 1. Okay, you see this? Okay. So now I can do negative sine of x. The negative sign is pulled out. This is replaced with 1. Okay. So minus 1 over 1 plus sine of x squared. Now, again, I have two things with a negative sign, so I can pull that out and make them both positive. So negative times the sine of x plus 1 over 1 plus the sine of x squared. So now, would you agree that sine of x plus 1 is the same as 1 plus sine of x? So that they're equal to each other. So now I can simplify this down and get negative 1 over 1 plus sine of x. And so that's why I'm saying it cancels nicely a lot of times and leaves you with something like that. Okay. In all honesty, the derivative part of these problems is probably not the hardest part. The hardest part is remembering those identities, canceling stuff out, and moving things around. It's probably the hardest thing with these whole problems. But anyways. Okay. All right, so the next one say a weight hanging from a spring bobs up and down with position function s is equal to f of t, s in meters, t in seconds. What are its velocity and acceleration at time t, and describe its motion? So basically, what this is saying is take the derivative 2 times. Is really what it boils down to. So, number 12, s is equal to 7 cosine of t So I want velocity, which is the derivative of position. So what would the derivative of 7 cosine of t be? What? What's the derivative of cosine? Negative sine, and I have the 7, so it's just going to be negative 7 sine of t. What 0?
What? Because the derivative of 7. Are we doing a product rule?
No, because it's just a number. So it's like if you had 3x squared. You leave the 3 attached to the x. You're treating your trig function now as your like x value essentially.
Oh, okay.
So the 7 just sticks with it and just moves down. So then acceleration is the derivative of velocity. So then what would the derivative of negative 7 sine of t? That was a mouthful. Yep, negative 7 cosine t. And those ones don't ask you for anything else. It just says at time t. If they were to give you a time that they wanted it at, then you could obviously plug that in for t after you've taken the derivative and find it. But that's not what that one asks for. Number 16, however, says a body is moving in simple harmonic motion with position function s equal to f of t. Find the body's velocity, speed, and acceleration at time t. And then find the body's velocity, speed, and acceleration at time t is equal to pi over 4. Okay. Now, I said find velocity, speed, and acceleration. Speed and velocity are very similar. What is true about them? Okay, so then speed has to be what? Positive or negative? Positive. So whenever I find the derivative of velocity at the time, or when I plug in the number, the absolute value of it is going to be the speed. Okay, so 16 is s is equal to the cosine of t minus 3 sine of t. So what I'm going to do here is I'm going to just say velocity, speed, and acceleration. So I'll do part A all the way across, and then I'll do part B all the way across. So part A, I want v of t is equal to what? So what is the derivative of position, or of the position? Negative sine of t minus 3 cosine of t. Okay, so if you, not that it really matters for this particular part, but in reality, you could rewrite this as the absolute value. All I'm going to do is this to show that that's the formula for it for speed. Okay, you could write the whole thing out if you wanted to in absolute values, but the speed part really only is an issue with part B when it asks you to actually plug in the value. And then what is the derivative of this to give me acceleration? The signs always get confusing when they're like negative times negative. It's like, yeah. That's another common error, common place for a mistake, just because it's just really easy to lose the negative sign. So, all right. So then now for part B, it wants it at pi over 4. So v of pi over 4. So negative sine of pi over 4 minus 3 cosine of hold on. Pi over 4. So what is the sine of pi over 4?
I'm having some more problems.
The sine of pi over 4?
Yeah.
Oh, sorry. Is it root 2 over 2?
Mm-hmm.
Okay.
So negative root 2 over 2. Then minus 3 times, what's the cosine of pi over 4?
The same.
Also root 2 over 2. Okay, so then in terms of trying to simplify this down, this gives me, let's see, negative square root of 2 minus 3 root 2 all over 2. So since these, remember we treat radicals like we would like a variable. So since it has a common radical, I can combine the numbers outside. So negative 1 and negative 3. So that's going to be negative 4 root 2 over 2. And then that simplifies to be negative 2 root 2. Okay, so the velocity at pi over 4 is equal to negative root 2 over 2. So then my speed is the absolute value of negative 2 root 2, which then is just 2 root 2. So that's my speed. So here, I'm going to do this so it's not confusing. And then I'm going to take and plug in the pi over 4 up here. So a of pi over 4 is equal to negative cosine of pi over 4 plus 3 sine of pi over 4. Yeah, it almost fits. It's just really squished together. All right, so we already said cosine of pi over 4 is root 2 over 2. So this is negative root 2 over 2 plus 3 sine of pi over 4 root 2 over 2. So that's going to give us 2 root 2 over 2, which is just going to give us the square root of 2. So a of pi over 4 is equal to the square root of 2. Cool. Any questions about those ones? All right, so then one more.
So speed is just the what's that? Just the velocity.
Yeah, just the absolute value of velocity. So it just has to be positive. So for 17 through 20, these ones say a body is moving in simple harmonic motion with position function. Blah, find the jerk at time t. So essentially, this is just telling you, go take the third derivative. But you're going to have to work your way down anyways. So you start with s is equal to 1 plus 2 cosine of t. So we're going to find v of t, a of t, and then j of t. So what is the derivative of position? Negative 2 sine t. The derivative of that? Negative 2 cosine t. And lastly, the derivative of that? Positive 2 sine of t. And so that would be the final answer that that's looking for. There. So, nothing too crazy. Like I said, the primary ones that you're going to see are going to be sine and cosine. we'll look at some of the problems tomorrow that have other trig functions in them when we do the finding the tangent and the normal line or whatever, those kind of problems. And what else? That's basically it. So, that being said, I'm going to go ahead and give you some problems so you can start making sure that you're understanding this before we get into the harder stuff tomorrow with this section. So 1, 5, 9, 11, 13, and 19.